Okay, guys, so today we're going to be this week we're going to be talking about arithmetic sequences. And so this is just, we're going to go over some definitions, and then we're going to go over some I'm going to see if I can pull up like my PowerPoint. So I'm going to be kind of all over the place, and then we're definitely going to do some examples on some graph paper. But definitely, for sure, before we actually like get into it, I do want to make sure you guys have the right definitions and the right formulas and all that stuff. So let me actually change the color. I like green. Yeah, green is nice. Okay, so let me zoom in. So that's pretty much the definition. An arithmetic sequence, oh my gosh. An arithmetic sequence is a sequence in which each term differs from one previous term. Oh my god. By the same number, okay? It's also called an arithmetic progression. So pretty much, it's just like a list of numbers where the way you keep going is you add or subtract that same number. For example, 2, 5, 8, 11, 14. Obviously, that's a sequence of numbers. So a sequence is pretty much just like, literally, it's just like a list. Okay. And the word arithmetic, in this case, it refers to adding or subtracting. Okay. And so the number that we're always going to be adding and subtracting, that is called the common difference. And this number can be positive or negative. Okay. So like in this case at the very top, 2, 5, 8, 11, 14, it's arithmetic. The common difference is positive 3. Okay. Don't let the word difference fool you. And here, the second one, the common difference is negative. The common difference is negative 4. So the common difference can be positive or negative. Okay, very, very important. All that matters, the only thing that makes any list of numbers, any sequence, the reason we can call it arithmetic is because you are adding / subtracting. Okay, and it's always that same value, whether it's positive or negative. It can be a fraction. It can be a decimal. It can't be 0. Cannot be 0 because then it's literally like the same number over and over again. So this is the formula. Oopsie. This is the formula for arithmetic, the arithmetic formula, arithmetic sequence formula right here. Okay, so we're going to go over that. We're going to go over the formula and how to use it. Actually, no, that's not the formula. I'm sorry, guys, that's not the formula. Ignore me. I will show you the correct formula. It's actually down here. It is very simple. So going back to the common difference, it is very simple to find the common difference. That's what this is saying. It's all it's saying is to find the common difference, which is labeled as D, right? It's labeled as D. To find the common difference, you just subtract the term and then the term before it. Okay, so 11 minus 8, or 23 minus, oops, let me make this thinner. where was I? 23 minus 27 gives me negative 4. So you got to be careful. It's always the one that, the latter minus the one that comes kind of first. Okay, so that's how you find the common difference. And most of the time, you can look at them and just know. So that's just how to find the common difference. And again, it's labeled as D. D for common difference, right? So, you don't really have to know that. Don't have to know that. Obviously, like I just went over, they're just repeating themselves. You don't have to know that either. Okay, this is what we care about. The general term formula. So, very, very important. Okay, suppose the first term of an arithmetic sequence is U1. So the first term is always U1, U sub 1. And the common difference is always D. All right. Oh my gosh. So down here, actually, let me just circle this. Let me highlight it. Well, I'll just underline it. So this is your formula. For the nth, this is your nth term. On the left-hand side, this is your nth term. This is your first term of the sequence that they provide. This here, D, common difference. And N, we'll figure out what N is. Oh, ouch. N is the number of the term. Okay, so make sure everything here that you see in this red box, I want you to make sure you have it written down. Okay, so the formula U sub N equals U sub 1 plus, parentheses, N minus 1, close parentheses, D. And that is the formula for the nth term. So the nth term, guys, is pretty much... Let me start writing some stuff. Okay. Definitely don't want that. Don't need that either. Don't even need that one. Okay. Where's the first example? Whatever. Okay, so make sure you have everything in the red box. Make sure you know that D is common difference. U sub 1 is the first term of the sequence. U sub N is the nth term of the sequence. And here we go. So U sub 1 is the first term. Okay, U sub N is the nth term. D is the common difference. Okay, and so you got to know what these represent. Okay. So let's go ahead. Actually, what I want you guys to do, I want you to copy this exact everything in this box, I want you to copy it into your notebook. In notebook. So go ahead, take a second, pause the video, and I hope to God you're using a computer and not your phone. If this was your phone, you'd have a very hard time. So go ahead, pause the video, and copy everything that you see. I want you to read it. I want you to understand it. So just pause here, and when you're done writing, I want you to start this up again so I can explain. Okay. So here we go. So say you have this sequence, right? Say you have there we go. Say you have this sequence. I want to write. Okay, there we go. Say you have this sequence 2, 9, 16, 23, 30, and it keeps going, right? It does not stop. It keeps going. So A, it wants to show that the sequence is arithmetic. In other words, does a common difference exist? So if a common difference exists, then the sequence is arithmetic. Okay? If a common difference does not exist, then the sequence is not arithmetic. It might be geometric, it might be something else, it might be no type of, it just be random pattern of numbers, or a random set of numbers. So first we have to determine whether or not the list of numbers they gave us is actually arithmetic, and that's by determining the common difference. So look at what they did. They got like 4 out of actually all of the pairs of numbers they give you. They subtracted 30 and 27 and 23. 23 and 16. 16 and 9 and 9 and 2. They got 7 every single time. So here in this case, there is a common difference, and the difference is positive 7. Okay, so yes, we have just shown that the sequence is arithmetic because a common difference, we found the common difference. Okay, so the difference between successive terms is constant. It's very important. B, find a formula for the general term, UN. Okay, very important. UN, also known as the nth term. Let me make this thinner. UN, also known as the nth term. So they want to know what the formula actually is. So, let's go down here. Zooming in. Okay, look at how they started. They started the entire formula. They started with the formula. UN equals U sub 1 plus N minus 1 equals, I'm sorry, not equals, times D. And so they want to find an equation for U sub n, so the nth term, or the general term. So my first term, U sub 1, they gave us that. That's 2. Okay? So they plug that in. Go back. Okay, and we did also determine the difference. We determined the common difference was 7. They pulled it in front here. And then the n minus 1 does not change because we don't know what n is. And so all they did was they just distributed that 7, and then they combined like terms to find that the general formula for u sub n is 7n minus 5. Okay? This is the formula for the general term. Very, very simple. You guys know how to do this. I know you know how to do this. Okay, so let's move on to part C. Find the 100th term of the sequence. Okay. What does that say? And then part D. Oh. Okay. I see what they did. Okay, so they want to know the 100th term of the sequence. So in this case, n equals 100. Oh my god, why is everything... So using the formula, so now we're just going to use this formula, right? 7n minus 5. So notice they replaced n with 100. Okay? Everywhere they saw n, they replaced it with 100. So 7 times 100, 700, 700 minus 5, 695. Pretty simple. Pretty simple. And so now part D, they are asking if these two numbers are a part of, are going to show up in this sequence. And they're huge numbers, so it's not like we can just, you know, hop a few numbers down the row and just say yes or no. We have to actually do the math. And so they want to know, is 828 a term? Okay. So this is what they did. U sub n, so the general term, we're just going to assume that we set it to that. So we're trying to see, are we going to get a whole number for n? Sometimes it'll work, sometimes it won't work. In this case, it does work, and I'm going to show you how it works. So they just checked to see if it fits into this formula. Okay, so they said, okay, let's pretend that u sub n is 828. So they plugged 828 in place of u sub n. See how they did that? Okay, and then they combined like terms. They added 5 on both sides. All right. Then they got 7n equals 833 divided by 7. They got n equals 119. So because this is a whole number, it works. And so, yes, 828 actually is a part of this arithmetic sequence. It's actually the 119th term. Okay, so n represents the number of that term. Okay, so now let's try 2341. Same process. They pretended, they were like, okay, let's pretend that 2341 is part of this sequence. And so they did the same thing. They solved for n, except look at what happened. They got an ugly, that's not a whole number, right? That's a mixed number, it's a decimal, same thing. N must be an integer. N must be an integer. So 2341 actually is not a part of this sequence. It's not a part of this list of numbers. So I like this example because it just explains really well. And so wait, hold on. I want you also let's go on to, so make sure you have example 2. Example 4 is very important. Make sure you have example 4. So just take a minute, pause it, copy everything from example 4. Okay, so go ahead and pause, and then we're going to talk about it. Okay. Okay, so let's go ahead and talk about example 4. So, find a general term for an arithmetic sequence, blah, blah, blah. So it gave us the third term. It gave us the third term and, no, I don't want that. Okay, gave us the third term and the 8th term. Okay, so they want to know the general term for the arithmetic sequence. They want to know the general, excuse me, general term. Okay, so this actually gets a little more difficult, but not too difficult. So look, they utilized this. Will you let me write? They utilized this formula. The same formula. It's the same formula. So now we're going to solve for, since we don't know our difference yet, we're going to solve for the difference first. And the way to do that is to utilize the information that they gave us. Right? So be very, very careful. So they said, okay, so the third term is 8, and the 8th term is negative 17. So they rewrote it like this. They said, here's what they said. They said, the first term plus 2 times the difference. So this number is always 1 less than this number. Okay, that is extremely important. So if you're trying to find if you have a problem like this, and it sounds like this, and it looks like this, and it gives you like weird, okay, this is like the 20th term, and this is like the second term, you can definitely figure out, that's enough information to figure everything out, but it's just very, very important that you use this kind of like setup, okay, to be able to determine the common difference. So, they rewrote this piece of information into this way. So u sub 1, so the first term, plus 2 times the difference equals 8. So remember, this term is always 1 less than this term. Okay? So now, excuse me, oh my gosh, they use the same process for the second equation. The 8th term, oh my god, the 8th term, which is negative 17, it is rewritten as the first term, same exact thing, plus 7 times the difference. So notice again, 7 is 1 less than this number. Okay, so equals negative 17. So now it's just like a system of equations. So this is what they do. This is what they did. They multiplied the first equation by negative 1, just so that something ends up canceling. But in all reality, this equation and this equation, the top one, are the same. But they just multiplied everything by negative 1. And so they did a little elimination, a little system of equations. And they came up with positive 5d equals negative 25. And then so they found d equals negative 5. Okay. So that is honestly the hardest part. After you figure out the common difference, it's really just smooth sailing from there. Because now that you know what the common difference is, you can use, hold on a second. They used this formula. They use this formula up here. So let me rewrite it. UN equals U1 plus, actually let me write it smaller. I like putting the D in the front, and then the common difference, n minus 1. Okay, so this is the formula they used to get here. Okay, and I'm going to show you how they did that. So UN is their 8th term. So they wrote it the wrong way, actually. So let me rewrite it actually in a better way. Let me rewrite it in the way they wrote it. U1 equal, U1 plus, they said that is so ugly, n minus 1 times the difference equals UN. Okay, I know it's sloppy, forgive me. So U sub 1, that's how they wrote it now. I wrote it exactly how they wrote it. And in this case, so right now, we're talking about UN, but UN is actually 3. Okay. So it's U sub 1 plus 3 minus 1 times negative 5 equals 8. So that's how they got that. So that's that 3 minus 1, and then that negative 5, and then that. So U sub n is your 8. So I'm sorry, I said it backwards. Your 8 is your U sub n. And so then all they did at that point was they solved for U sub 1. And then they went back and they said, okay, now we know what the common difference is. Now we know what the first term is, which is U1. We can finally figure out the general formula. Okay, so they plugged in everything they knew here, and then they just solved for U sub n for the general formula, and then that is it. Okay, I know it's a lot. I wish I was teaching this in person. And here they just check their work. You can always check your work. But Yeah. Okay, don't want to do that. Okay, so those are actually two of the best examples. You have you know what everything means. You know what everything represents. Example 3, nah. Okay, so now let's go to my slides. Let's see if I skipped anything that I want you guys to do or no. Okay, so you know that. Okay, you know that. If you see something you like, go ahead and pause it. Ooh, I should have done this first. Next time I'll do this first. In regular words, it's a list of numbers where we add and subtract the same integer to get the next number in the list. Okay, so here I went over the difference can be positive, the difference can be negative. I do want you guys to write these examples down. Very, very important. So just pause and write down both of these examples. Okay, you can write down anything you like actually, but I do think I want you to definitely have these written down. So just take a minute and pause. And I'm going to move on. Don't want to cover that. It's already been like 30 minutes. So we're just going to do a couple examples and then we'll be good to go. So let me get my textbook. Just give me 1 second, guys. Excuse me. Okay, so what I say, page 42 and, page 42. Okay, so let's open this again. Alrighty. So, oops. Arithmetic sequences. Examples. Okay. So let me see here. So let me go ahead and rewrite the formula. Why is that so thin? U sub n is equal to u sub 1. I'm going to put the common difference there. I just like it better there. Same thing. This is the formula. This is the magical formula. Okay, and just so you guys remember, this is the general nth term. This is the first term. This is the common difference. Okay. Make sure you know all this. So there is a lot of manipulation and algebraic maneuvering with arithmetic sequences. So practice is definitely necessary. Let's see here. Okay, so let's consider the sequence 6, 17, 28, 39, and 50. It keeps going, guys, but you know what? Let me just erase it and start over. Let me... So we said 6, 17, 28, 39, and 50. Okay, so we can easily determine the common difference. So the question is asking me, show that this sequence is arithmetic. So in other words, does a common difference exist? Okay. So find D, if any. Alrighty. And so the easiest way, if you can't just look at it and tell, the easiest way is just to start subtracting. So 50 minus 39, I believe that's 11. 39 minus 28, also 11. 28 minus 17, also 11. So there's obviously, 11 is obviously the common difference. Okay. 11 would be the common difference. I want to say it's positive 11. Okay, so positive 11, that's the common difference. Now let's go, make sure you have everything written down. I'm about to go to the next page. So now let's find, so next question, find the formula for this, for the general term. So 6, 17, 28. So let me rewrite everything. So D we decided was positive 11. So now it wants us, what is the common, what is the formula of the general term? Okay, and so we're going to use this formula in red, except we're going to fill in what we know. All right, so U sub n, so I'm just rewriting the formula. Okay. Do I know what the first term is? Yes, I do. It's 6. And I know what the common difference is, which is 11. It doesn't talk about what exact, like it doesn't say, oh, I want the 20th term. So we don't know what n is. We're just writing a general term. So U sub n is 6, following the formula, plus 11 parentheses n minus 1. We aren't done yet because we do have to start distributing and simplifying. So U sub n equals 6 plus 11n minus 11. U sub n equals 11n minus 5. Okay, so that's the general formula. That's the general formula for this sequence in the blue box. Okay. So make sure your video is paused so that you can catch up and write everything. Go ahead and pause now. Okay, so moving on. So what is it? 6, 17, 28. So again, same. We aren't done yet. Okay. So I have determined now, very important information. What did I say it was? Say it was 11n minus 5. Okay. So 11, oops. 11n minus 5 is the general term. I'm sorry, the general formula. So now I can determine any term that I want. I can determine the 20th term, the 9th term, the 100th term, which in this case that would be, so n would be 20 there, n would be 9 there, n would be 100 there. And so by the next question is asking me, find the 50th term. Okay, it says find the 50th term, Noor. Go away. Find the 50th term. So in this case, n equals 50. And now it's just very simple plugging into the general formula. So u sub 50, so that is read as the 50th term. So that's read as a 50th term equals 11, 50, n equals 50, minus 5. And now we're just going to do some algebra. So the 50th term is equal to 550 minus 5, which is 545. Okay, so that's the 50th term. Make sure your video is paused so that you can get this good. This is a great example. And so now it's asking me, is 325 a member? If I had to guess, I would honestly say yeah. Just because it looks like, I mean, that's just my guess. I could be wrong though. Let's see. So now it's asking me, I'm going to rewrite it, 6, 17, 28. Okay, and the general formula, we said it was 11n minus 5. And so now it's asking me, is 325 a part of this sequence? And so we're just going to pretend, right? We're going to pretend, and we're just going to plug 325. We're going to replace 325, the number they gave us, right here. And then we're going to see if we get an integer for n. We're going to solve for n. And then if we get an integer, so remember that's a positive whole number or a negative whole number, or 0, then yes, it is a part of the sequence. If we get an ugly number, like a mixed number or a fraction or a decimal, then no, it is not a part of the sequence. So now we're just going to solve for n. And it looks like we have a winner. Beautiful. Beautiful, beautiful. So pause here, make sure that you have everything. We're going to move on. We're going to do one more portion. We're going to determine, is 761 a part of this sequence? So moving on. So n equals 11 and, erase. U sub n equals 11 n minus 5 is 671. I'm sorry. That's not what it says. 761 a part of this sequence. So we're going to take this number and then we're going to divide it. We're going to pretend it's the nth term. Yep. So 7, we're going to plug it in. 761 equals 11n minus 5. I don't think so, but let's see. We're going to solve for n. So if we get a whole number, positive, negative, an integer, okay? If we get an integer for n, then it is a part of the sequence. So that's 766 equals 11n. Ooh, don't think so. So n equals... my calculator. Calculator's dead. I have a backup calculator. 69.6. Actually, just keeps going. 63636. So, because it's a decimal, no. No. The answer is no. It is not a part of this sequence. Okay. So, pause here. Make sure you have everything. We're going to do one more example. And then we're just going to close the video out. Okay, last example. So let's see here. Find the general term U sub n for an arithmetic sequence comma, given that the 7th term is 41 and the 13th term is 77. Okay, so make sure you have this copied correctly. And then we're about to solve. Okay, so U sub, so the 7th term, what did they say, 41, and then the 13th term was 77. So we're going to rewrite these two pieces of information into something a little more algebraic. Okay, a little more algebraic. Because we want to manipulate. Okay, that's the goal. And so, U sub 7, dang, undo, yes, okay. So we're going to rewrite this as this. So right now it's saying the 7th term is 41, right? So now the first term plus 6 times the difference equals 41. Dang it. Okay. So that's the first equation. Oh my god. Let me rewrite it. Let me make myself some more room. So if u sub 7 is 41, then the first term plus 6 times the difference also equals 41. This is very important manipulation of the facts. Okay? And when I say manipulation of the facts, I don't mean it like in a bad way. We just rearrange the information into something that we can work with. Okay? And so now we're going to do the second one. So notice this number is 1 less than this number. This number stays the same except it's over here. Okay? So now we're going to do the second one. So u, the 13th term, they said it was 77. Okay, well, I'm going to rewrite that. So the first term plus 12 times the common difference equals 77. So I like these much better in the blue boxes than the, the other ones that they gave us. So pause here and make sure you have it. So I'm going to move on to the next page. So u sub 1 plus 6d equals 41. And then we also said u sub 1 plus 12d equals 77. And so now we're just going to use, this is a system of 2 linear, linear. Well, oopsie. I'm just going to call them 2 equations. So we're going to use the process of elimination to determine what the common difference is. Okay, and so make sure you write that down. Actually, I can just write it again. So u1 plus 6d equals 41. And then u1 plus 12d equals 77. So I'm going to go ahead and just multiply the entire first equation by -1. And move on to the next page. So pause if you need to. So that's negative u1 minus 6d equals negative 41. And then the second equation stays the same. And now we're going to solve. So that becomes 0. So that becomes positive 6d. Negative 41 plus 77. So that's just 77 minus 41. Make sure I don't make mistakes. Don't want to, this is a very important example. So now we have 6d equals 36. Now we just solve for d. So our common difference is positive 6. Very, very important. That's honestly the hardest part. And so pause if you need to. So now that we know what our common difference is, we're going to figure out. Now we determine the first term using d equals 6. Okay. So un, so same formula, un equals u1 plus d n minus 1. So in this case, oopsie, what is it? Is it, they said, oh, okay, they said 41. So 41 is equal to u1 plus 6. So if you recall, this is our original piece of information. Okay, so the 7th term is 41. And now we determined what the difference was. And so n minus 1 is, which is 7 minus 1. So n is 7. So 41 equals u1 plus 42 minus, oh, I took it the long way. 42 minus 6, 41 equals u1 plus 36. So then subtract 36 on both sides. u1 equals 5. Okay. So we know what the common difference is. We know what the first term is. Now, our handy dandy formula we just plug in everything we know. Plug in all the information we just found. Okay, they did not give us these. We figured these out on our own. Now we're just going to plug them in. So u sub n equals, the first term is 5, plus the common difference is 6, and minus 1, 5 plus 6 and minus 6. So the general formula is 6 and minus 1. Oof. Oof. Go ahead and pause here. Make sure you understand everything that just happened. I really don't want you guys to just... I really want you guys to learn. And I know that it's not easy with math and with virtual stuff, but just try your best. You know, we're all just trying our best. And so, that's really it. That's the end of this video. So, let me actually see one tiny thing. Hold on a second. Okay, no, never mind, forget it. So that's the end of this video, guys. Thanks for watching. As always, you can, if you like my slides, my Google Slides, I'll start with that next time, definitely. Definitely just go back and pause, because I know in the beginning that me writing in the textbook was very like messy and chaotic. So next time I will definitely start with the slides. But just for this video, you can just go ahead and rewind to where I was with the slides. I know I make them really cute and nice. And just email me if you have any questions, concerns. I miss you guys. Be safe, and I will talk to you guys tomorrow.